one, decision tree. Decision tree, we talked about briefly, but let me add another example to it and add a little more detail, and you'll appreciate the power of machine learning by seeing how it does internally. So decision tree. Decision tree, as we saw before, you start with a question, with a pointed branch, and then you keep on asking questions and keep on going to the leaf, and finally you'll come up with some kind of category that will. Let's say we take this data, there is this thing called short attractiveness. Like you just suddenly see somebody's photo, you meet somebody in Starbucks, just see kind of thing, just like, oh, just look back, or kind of thing. That's called a short-term attractiveness. And let's say we put in the data and try to say what is more important, what kind of thing is more important to get short-term attractiveness. So data provided to us is facial symmetry, BMI, right? Waist to hip ratio, and how well groomed the person is. So these are 4 data sets, 4 features provided to us, right? In the terminology of data science, these are 4 features to I think. Now, when I feed this thing, first of all, everything is numeric, so it's all good. I don't need to do conversion, right? Female, male, which conversion? I don't need to do that. So it's all good. I can feed this to the decision tree model, and the decision tree will try to take this data, plot this data, facial symmetry and BMI and all of those kind of patterns, and it will iterate and iterate internally, and it will tell the number one thing is symmetry. How symmetrical your face is going to define the most short-term attractiveness aspect of it. So being average actually is actually good. Being symmetrical and average is very good. Average is attractive. This is simply a word. You don't have to be fascinating that way. The first one, so I did not tell, I'm not picking up as a data scientist, I'm not picking up which field is important. The data, the algorithm is going to pick up by itself. I just give this data and says, oh, symmetry is the number one thing. And it not only says symmetry is important, but it says how much important. It's 0.8 of symmetry is good enough. When you bind everything, that makes a big distinction. Then I'm going to check more details. The BMI is the second one. And then how well groomed the person is. That's the third one. So it figures it out automatically, learning to the data and model kind of a thing. And it will create this picture, literal picture by itself. It will spit out a picture, which will say all these values. Oh, BMI has to be this much and everything just based on the data. So that's what decision tree is trying to do it. In pictorially, it is doing through this kind of a step-by-step process. So first step, when it goes through it, it's kind of divided these 3 into different kind of things, whether it is attractive, somewhat attractive, not attractive. In the second pass, when it goes through, when I say second pass, means I'm going to the second branch, which we call as the depth of the tree, how deep the tree is. So this when you move to the second iteration, it changes, and third iteration, it changes, and that's probably the final one, which we have this kind of a structure built in. So it goes through this tree step by. First of all, it builds the tree. Each iteration, it keeps on changing the data. It says, okay, now this person is attractive versus not, versus moderately attractive, and all of that, and finally comes up there. There's 2 very commonly used models, very, very common and very important ones to define that. We talked about a regression one. We talked about this as a classification one.